You can do it if you believe you can. Hi, everyone. In this video, I would like to go through the test number 4 major topics review session. So the 4 major topics we're going to go through are number 1, solve for angle theta. Number 2, word problems. Number 3, solving triangles. And number 4, the ambiguous case. And again, I would strongly encourage you to do this while watching the video. You can pause and play as you need. And of course, next to each example, either you can put a check mark to indicate that you fully understand this, or put an X if you have no idea what to do yet. And of course, sometimes there's the in-between case, and you can put a question mark next to those examples accordingly. Let's begin. Number 1a, solve for x, where x is in between 0 degrees and 360 degrees. And I guess we should put the inclusive symbol there, even for these ones, just like that. So in 1a, it says cosine x equals to 0.5. So again, step 1, draw a diagram. When you think about the 4 different quadrants, CAST, it's important to understand that cosine is going to be positive. So in this case, it's going to be in quadrant number 1, and it's going to be quadrant number 4. Again, think about 0.5 as 1 over 2, and cosine is going to be adjacent over hypotenuse. So adjacent is going to be here, hypotenuse is going to be there. And again, think about the 2 special triangles. For example, if it's going to be 2 and 1, the other side is going to be root 3, and this one's going to be negative root 3, respectively. Anytime you're going to the right or you're going up, those are positive numbers. When you're going to the left or going down, those are negative numbers. And of course, this is going to be 60 degrees, likewise 60 degrees. Now, there are 2 answers. So again, one answer is going to be right here, and that's going to be 60 degrees. If you grab a different color, the other answer is going to be right there. Let's do it again. It's going to be right there, which is going to be 360 minus the related acute angle. So 360 minus 60 degrees, which is going to be 300 degrees. Now, here's the most important step, everybody. In case you are not confident that this is the right answer, here's what I'm going to recommend for all of you. Spend 1 extra minute. You're going to double check all your answers, and I'm going to show you right now how that is done. So again, I grab my calculator. I'm going to press cosine of 60 degrees. So you turn it on. You make sure you're in degree mode. You press cosine of 60. You press equal, and I see 0.5. Again, I press cosine of 300 degrees, and when I do that, I also get 0.5, and that's the best feeling I can offer you, knowing that you already got 100% while doing this question. Example 1b, cotangent x equals to 1 divided by 3. So again, be mindful that cotangent of x is the same as 1 divided by tan x, which equals to 1 divided by 3. Again, you can cross multiply or you can take the reciprocal, but when you take the reciprocal of the left-hand side and the right-hand side, you will get tan x equals to 3. Again, we go back, we're going to draw a diagram. Remember CAST, and the only quadrants where tan is going to be positive is going to be in quadrant number 1, and of course, quadrant number 3. Now again, be mindful, in this case, tan is going to be opposite over adjacent. So 3 could be thought of as 3 divided by 1, so 3 and 1. Now, you're not always going to get a special triangle. So for example, in this case, it is not a special triangle, and that's fine. You're going to grab your calculators, make sure in degree mode, you take the inverse tan of 3. When you press equal, you're going to get 71.6 degrees. I'm rounding it to 1 decimal place. That is the related acute angle. So this angle right here is 71.6, likewise 71.6. So again, we found the first answer in a different color. To find the second answer, you're going to take 180 degrees. You're going to add it to 71.6 degrees. And when you do that, your second answer is going to be 251.6 degrees. Again, that's approximate to or rounded to 1 decimal place. How do we know we're doing it right? Now, this is where you want to be very careful. To double check this question, you cannot just grab your calculators and press cotangent. So again, most scientific calculators, to my knowledge, only has sine, cosine, and tan. You're not going to find secant, cosecant, cotangent, but it doesn't mean you can't double check. You just got to be a little bit careful. So instead of going through cotangent x, you're going to take 1 divided by. So what we're going to do is we're going to take 1 divided by 10 of 71.6. Now, when I do that, again, be mindful, we're not going to get the right-hand side with 100% accuracy. It's going to be an approximation. So I grab my calculator, I take 1 divided by 10 of 71.6, and it's going to be 0.3326555724, which is pretty much 1 over 3. It's close enough. So we know the first answer makes sense. Again, to double check the second answer, I press 1 divided by, and I'll write it out for you. 1 divided by 10 of 251.6. When I do that, again, I get 0.3326555724, which is approximately 1 over 3. So the best feeling I'm offering you is if you're willing to double check, which is an option, you can get 100% within the same time frame of this example. Example 1c, cosecant x equals to negative 2.5. So I would like you to pause the video, try this first, and when you press play again, I'll be here. Welcome back, everybody. So again, if you think about cosecant x, this is 1 over sine x. When you think about negative 2.5, you can leave it as negative 2.5, or you can leave it as a fraction, which is negative 5 divided by 2. Again, your goal is to isolate for sine x. So if you take the reciprocal of both sides, sine x is going to be negative 2 divided by 5. Now, this is not a special triangle. That is totally okay. You're still going to draw a diagram recognizing CAST. Now, in this example, the only quadrants where sine is going to be negative is going to be quadrants 3 and 4. So I go back and I just draw the triangles. I grab the calculator. I take the inverse sine of negative 2.5 or negative 2 divided by 5. And again, you're going to get negative 23.6 degrees. That is not the final answer. Remember, angle x has to be in between 0 and 360. So what you have to do is 2 things. First of all, negative means you're going clockwise. That's going to be 23.6. That is the related acute angle. And the second step is you want to add 360. So take that number, negative 23.6, add it to 360. So I'm going to use a different color to show you what I'm talking about. So one answer is going to be approximately 336.4 degrees. That's the answer right there. Now, if I grab a different color, again, the other answer is going to be right here. And for that one, you can take 180 degrees. You're going to add it to the related acute angle, 23.6 degrees. And again, if you work it out, again, you can use mental math. You can grab a calculator. That's going to be 203.6 degrees. Now, not to overstate this, you can totally get perfect by double checking. Here we go. One more time. If you look at the left-hand side, cosecant x is the same as 1 divided by sine x. So 1 divided by sine of 336.4. If I use my calculator, I'm going to double check right now. That's going to be approximately negative 2.497820448, which is pretty close to negative 2.5. So this verifies that the first answer makes sense. Likewise, if I double check the second case, I can take 1 divided by sine of 203.6 degrees. This is going to be, again, negative 2.497820448, which is approximately negative 2.5. Example 1D, 10x equals to negative 4. Again, by inspection, this is not a special triangle, and that's fine. I go back, I look at C, A, S, and T, fully recognizing that the only quadrants for a negative 10 is going to be quadrants 2 and 4. So I take the calculator, I take the inverse 10 of negative 4, and it says negative 75.96, so roughly negative 76 degrees. Again, negative means you go clockwise. So the related acute angle is going to be 76 degrees, which means, again, one answer is going to be 180 minus 76. And if you work that out, it's going to be 104 degrees. If I grab a different color for you, the second answer is going to be there. And that's going to be 360 minus 76 degrees, which again, if you work it out, that's going to be 284 degrees. Now, one more time, I'm going to double check with you to encourage you that you have the power to get 100%. It is an option that I would encourage you to consider. So again, if I want to double check, let me just kind of divide this. I double check by grabbing a calculator and I take 10 of 104. Now, when I do that, I will get negative 4.0107800934, which is really, close to negative 4. Again, if I grab 10 of 284, this is going to be negative 4.0107800934, which is again approximately negative 4. So as you can see, anytime you're trying to solve for x, you can totally get perfect by double checking. Example number 2, an underground sprinkler system is laid at an angle of 34.5 degrees to a fence. The sprinkler jets are 10 meters apart and have a range of 12 meters. Determine the length of the fence that gets wet from the sprinklers to the nearest tenth of a meter. Now, this is a question where you have to look at each possible case. So I'm going to highlight this for you. Right now, it says the sprinkler jets are 10 meters apart. So you go back to the diagram and you recognize all these points that I've given you. This is 10 meters. That's another 10 meters. That's another 10 meters. There's another 10 meters. Like if you kept going, it just continues like that. Now, if you really think about this, there are a couple of cases. Remember, the range is 12 meters. So there are only two cases. Either it will reach or it will not reach. So what I mean is this. Imagine drawing this line here and draw a line here and here and here and here. The question is, if this is 12 meters, where does it actually connect? And how do we know this? So this is kind of that ambiguous case idea that you want to test out. So the first thing you want to do is compare 12 meters relative to each case. So you can compare it to, let's say I start from here. Let's see if this is going to work. Let's pretend I'm connecting this. I'm not saying this works. I'm saying I want to find out if this works. So let's say this is going to be 30 meters right there. I need to know, does this even work? So I'm comparing two things. I'm comparing 12 relative to 30 sine of 34.5 degrees. So again, remember, when you think about the ambiguous case in general, I'll put this in the left bottom corner for you. So you can always redraw this, but the point is you're comparing a triangle where you're given an angle. Let's call this angle A. And of course, you have length A. And of course, you have length B as well. And the key becomes, what is the comparison? Well, I know this height in general, which we talked about. Height, this is going to be equal to B sine A. And you're comparing to the length. So when you're comparing to the length A is actually there somewhere. You want to know, okay, is A going to be greater than? Is it going to be equal to, or is it going to be less than? That's always the question. And again, depending on the answer, you can get two triangles, one triangle, or no triangles. So again, to be clear, you're comparing in this context 12 with one of the many cases. What happens when you take 30 sine of 34.5? So again, I'm going to grab a calculator. I take 30 times sine of 34.5. That's going to be, this is going to be 16 approximately, 16.99, so maybe I'll round it to 17. So you can see 12 is going to be less than 30 times sine of 34.5. So what that means is the water from the starting point is not going to reach to the fence if you're talking about this point. And if you can call this point, let's say D, we're saying that the water from D will not reach the fence. So this is not going to work. And that's okay, because we need to figure out which one does work and then solve it. So again, I'm going to go back. I'm going to try this again. Write down 10, 10, and 10. So the next step becomes, well, what about this one? What if I'm looking at the case where I'm going all the way to here, which is 20? So again, I go back. Maybe I'll grab a different color for you. I'm comparing 12 with 20 this time. And this 20 is here. I'm going to color code this for you. The 20 came from there. Sine of 34.5 degrees. So again, if I grab my calculator, 20 times sine of 34.5 is going to be approximately 11.32812474. So approximately 11.3. So 12 is going to be greater than. So this means this could work, right? You can actually reach all the way to that point. So now we're going to work with those numbers. So again, there's a triangle now. I'm going to erase everything else. Write down 20. And now we can go back and determine the length of the fence that gets wet from the sprinklers to 1 decimal place. So the way we do this now is we need to find the missing angle. And the missing angle in this case is going to be angle, let's call this angle E. Again, you can call this any angle really. So we don't know what E is yet. So you go back, let me erase this line. And you write down sine E, so applying the sine law, sine E divided by 20 in this case equals the sine of 34.5 degrees divided by 12. Now again, you can do this in one step. You grab the calculator, you press 20 times sine of 34.5, divide this by 12, you take the inverse sine of the answer, and this is approximately 70 point. Now it says round to 1 decimal place. So it's 70.7363461. I'm going to round it to 70.7 degrees. So I'm going to go back and label this. This is going to be 70.7 degrees. I'm also going to erase this note that we had earlier from the right bottom corner. So the angle E, is approximately 70.1 degrees. What does that really mean? We can also find the other angle. So let's go back. The third angle, of course, you can take 180 minus 70.7 degrees minus 34.5 degrees. Again, if you want to grab a calculator, that's fine. When you work it out, this equals to 74.8 degrees. So I'm going to go back and write this as well. 74.8 degrees. Now, again, if you kind of look at this carefully, you want to find the missing length as well. And to find the missing length, you can apply the sine law one more time. So if I call this point A, the question becomes, what is this length, EA? And of course, EA divided by sine of 74.8 degrees equals to, I'm going to go back to the original, 12 divided by sine of 34.5 degrees. Again, if you grab your calculators, you can take 12 times sine of 74.8, divide that by sine of 34.5, and that's going to be approximately 20.4. Now again, the question says determine the length of the fence that gets wet from the sprinklers to the nearest tenth. So we're going to grab a text box. We're going to write down a final statement for you. So I would say in one sentence, let's put it at the bottom here. Therefore, the length of the fence that gets wet is about 20.4 meters. Example number 3. So by inspection is a 3-dimensional diagram on the right. And of course, we can read the whole paragraph. Sometimes you can even solve this from a different perspective. So yes, we can read the entire example to measure the height XY of an inaccessible cliff, so on and so forth. But here's another approach I want to share with you. You don't always have to read the whole paragraph word for word. Sometimes you want to extract the most important information. So again, if I begin with the end in mind, I'm going to start with the last sentence here. It says, find the height of the cliff to the nearest tenth. So that's your goal. We want to find the height of the cliff. So I'm going to go back and look at the diagram. This is the cliff. and the height is going to be xy. So even without reading the whole thing, I can tell, all right, what is my goal? My goal is to find the height of the cliff to one decimal place. Great. What is given to us? We have all these numbers, and there's one number that we haven't looked at yet. So now I can go back and read it. Inaccessible cliff, a survey recorded the data shown. Now, the only add-on is the height of the person here, which is 1.7 meters. So that's something we want to consider at the very end, right? So again, we go through the same calculations, but then at the end, we look at that into consideration. Now, if you go back to the diagram, there's so much going on here. If I grab a different color and color code this for you, there's a triangle right here. And in this triangle, there's a lot we can solve for. So there's a 90 meter, there's a 35.8 degrees, there's a 44.2 degrees. So let's talk about what we need in order to get to where we want. So first of all, we need to find this angle, because you can find angle VXW, then you have one pair, you have a second pair, which means once you find the angle, then you can find the length in VX. Once you find that, you look at this and you say, oh, it's a right angle triangle. And from here, you have pretty much the angle, the length, and you can find that by using SOHCAHTOA because it's a right angle triangle. So I'd like you to pause the video, try this first. Those are the steps. So give it a try. And when you press play again, I'll be here. Welcome back. Let's solve this. I'm going to go back, erase all these steps. I'm going to start with step number 1. All right. So very doable. You can do this. Here's the first step. I need to find the angle. And of course, to find the angle, I can go back and look at 35.8 degrees, 44.2 degrees, which means this angle, again, it's going to be 180 minus 35.8 minus 44.2 degrees. When you work it out, this equals to 100 degrees. So I'm going to go back and label this as 100 degrees. Okay, that's step 1. We found the angle. Fantastic. Step 2 is to find the length xv. So I go back. I'm going to grab a different color. To find xv, I can apply the sine law. So xv divided by sine of 44.2 degrees equals to, I can take 90 divided by sine of 100 degrees. Again, you can grab your calculator. We're going to round this. I take 90. I multiply this by sine of 44.2 degrees. Divide this by sine of 100. That's going to be 63.712799985. If I round to one decimal place, it'll be 63.7 meters. So I'm going to go back and label this. That's going to be 63.7 meters. The hard part is now over. If I look at this triangle, again, remember, it's a right angle triangle. That's the key. It's a right angle triangle. So this is going to be 63.7 meters. That's going to be 31.1 degrees. Our goal is to find the height of the cliff. Remember, xy is not the height of the cliff. The person standing right here, by the way, so I'm going to kind of connect this with you, which is the final step in a moment. But if you go back, opposite over adjacent. So again, tan of 31.1 degrees equals to xy divided by 63.7 meters, which means xy equals to, you can take 63.7, multiply by tan of 31.1 degrees. That's going to be 38.4 meters. But again, our goal is to find the height of the cliff. So height of the cliff is going to be 38.4 plus 1.7. Don't forget the 1.7. That's going to be approximately 40.1. So again, to make this very clear, we're going to add a final statement. Therefore, the height of the cliff is about 40.1 meters. This there. Let's do it better for you. Just like that. Example number 4. A rescue helicopter flew from its home base for 35 kilometers on a course of 330 degrees to pick up an accident victim. It then flew 25 kilometers on a course of 90 degrees to the hospital. What distance and on what course will the helicopter fly to return directly to its home base? Again, I would like you to pause the video, start with the diagram, try to solve this. When you're done and you press play again, I'll be here. Welcome back, everybody. Now, the most difficult part, I would say, is the diagram. Once you see the diagram, then I would say the hard part's over. So what I really mean is this. Start with the following ideas. You need to really make a reference frame. So I have one right here, for example. Now, in the first sentence, and I'll grab different colors for you, it says a rescue helicopter flew from its home base for 35 kilometers on a course of 330 degrees. So 330 degrees. You start from here, you go all the way to 330. What does that really mean? You draw a straight line, which looks roughly like that. Now, the length of this line is going to be 35 kilometers. If this is going to be 330 degrees, this angle is going to be 30 degrees. So all I did was I translated from English into a diagram, which then I'll work on the math accordingly. In the next sentence, it says it then flew. So notice it just continues. So that gives you the hint that you're going to set another scale right there because it continues flying. And of course, if I go back to the first color for your reference, a course of 90 degrees to the hospital. Now, 90 degrees means you go from here all the way to here. So you're going straight north and you're going at 25 kilometers. So again, roughly speaking, 25 is going to be something like that. It's not a perfect diagram, but it's good enough for the purpose of this example, 25 meters. The question says what distance and what course would the helicopter fly to return directly to its home base? Now, you got to be very mindful here. You want to go home. So I'm going to draw an arrow for you. We're not doing vectors. That's a grade 12 topic, but I'm drawing an arrow so you know where you're going. This is home. They started here. They want to go back to the same original spot. So the question really becomes two things. You want to find the length. You also want to find the angle. So I'm going to say this is the length. Let's call this x. Let's call this angle theta. Those are the two unknowns we're going to solve for. So again, here's what you can do. Think about the cosine law. Think about side angle side. So the fact that this is going to be 30 degrees, I hope you recognize this is going to be 60 degrees because this is a right angle triangle, right? So you go back and you say SAS. That's the cosine law. Again, cosine law is c squared equals to a squared plus b squared minus 2ab cosine c. In this context, x squared is going to be 35 squared plus 25 squared minus 2 times 35 times 25 cosine 60 degrees. Again, to find the opposite of squaring something, you're going to find the square root. Grab your calculators. In degree mode, let's work it out. So if you work this out to one decimal place, it's approximately 31.2249899, which is rounded to 31.2 kilometers. So again, that is the distance that they're asking for. But the second part is what course. Course means angle. And of course, to find the angle, you can use the sine law, sine theta divided by 35 equals to sine 60 divided by 31.2 in this case. Again, you can grab your calculators, take 35, multiply by sine of 60, divided by 31.2, take the inverse sine of the answer, which is approximately 76.1 degrees. And now here comes that final statement, right? And this is where you want to be a little bit careful. So mathematically speaking, you can say you have to travel 31.2 kilometers south, 71 or 76.1 degrees west. So maybe I'll write it like that. And I'll say it in a sentence. So let me grab a text box. Let's write it for you like this. Let's fit this on the right bottom corner. Therefore, The helicopter will fly about 31.2 kilometers south, 76.1 degrees west. Now, of course, that's not the only answer. So if you want to rewrite it in the same format as what they've given you, that also works. So another way of doing this, let's say you don't want to write down 71.6 degrees, south 76.1 degrees west. Another way you could also express it according to the question is this. Maybe I'll give it a different approach. If you take 270, you subtract 71.6, that's 193.9. So you could also say flying, the helicopter will fly about 31.2 kilometers on a course 193.9 degrees. So let me explain this before we hop over to the next example. Let me just put this in the corner for you. Okay. The reason why you can also write it like that is because, if you go back to the same setup, isn't it true? This is the angle you're talking about. And that angle is really 270 minus 76.1. So that's why this angle is going to be 193.9 degrees. So maybe that's a better format to keep it consistent with the way the question was written. Example number 5. A house is 7 meters wide and 20 meters long. The roof slopes at an angle of 35 degrees as shown. The two rectangular parts on top of the roof are to be shingled at a cost of $25 per meter square. Calculate the total cost to the nearest dollar. Again, pause the video, try this first. When you press play again, I'll be here. Welcome back. So this is the solution to example number 5. If you think about this, the first step is you want to find the area of both sides. So there's the right-hand side, there's also the left-hand side. Once you find the area, then you're going to multiply by $25, which will give you the total cost. Now, if you go back to step 1, before you can find the area, you need to find the missing length. So again, notice what we can do is we can draw a triangle, which is this triangle. I'll just give you the same color for your reference here. And I can call this X. Now, if this is going to be 35 degrees, and that's going to be 35 degrees, that's going to be 70 degrees. 180 minus 70 is going to be 110 degrees. This is going to be 7 meters. So to find X, you can apply the sine law. X divided by sine of 35 degrees equals to 7 divided by sine of 110 degrees. Again, I'm grabbing my calculator. I'm going to work this out with you right now. So 7 times sine of 35 degrees, divide this by sine of 110 degrees. That's going to be approximately 4.27271161, or approximately 4.3 meters. So I'm going to go back and label this. That's going to be 4.3 meters. The other side is going to be 4.3 meters because this is an isosceles triangle. Now, once you know that, again, the hard part's over because to find the total cost, what you're doing is this. You know the cost is going to be $25 per meter square. And we need to find the area. There are 2 of these. So 2 times the area of each side is basically length times width, which is going to be 4.3 times 20. So again, you can grab a calculator. I'm going to work it out with you. 25 times 2 times 4.3 times 20. It's going to be, roughly speaking, $4,300. Again, let's write a final statement. Here's a text box. Okay. Therefore, the total cost is about $4,300, just like that. Let's put it right there. And that's how you solve example number 5. Example number 6, and there are 4 parts in this one. Determine the number of triangles that could be drawn with the given measures, then find the measures of the other angles and the other side in each possible triangle, round to the nearest tenth if needed. So again, be mindful. There are 3 cases. Sometimes there'll be no triangles. Sometimes there'll be 1 triangle. Sometimes there'll be 2 triangles. Those are the only 3 cases that you need to think about when it comes to the acute triangles. Obtuse, there are 2 other cases, but I don't think we need to use that for example number 6. So here's the first step. Again, always put the angle on the left bottom corner. That's a good way to set up your triangle. So it doesn't matter if it's angle ABC or a triangle ABC or GHI in this case, it's the same setup. So the first information is 20 degrees. That's going to be angle G. So write down 20 degrees, left bottom corner, that's the angle. Now the opposite side here is going to be 2 centimeters. And we don't know at this moment if it's going to be long enough to form 2 triangles, or if it's going to be long enough to form 1 triangle, or if it's going to be not long enough to form any triangles. We don't know that yet. So what we're going to do is we're going to find out. And we can find out by comparing it to the other value, which is 5 centimeters in this case. So angle H is going to be there. So what we're trying to do in this case is we want to compare the number 5 with B sine A. Again, if I take a step back, B sine A in this case is going to be 5 sine, oops, it's not 5. You're comparing 2 actually. Let's try this again. You're comparing the length 2 with 5 sine 20 degrees. Now again, just to make sure this is clear, what you're trying to do is this. You want to find this height. And we know that now this height is confusing because I wrote down H there. So maybe I'll use capital H. This height that we're talking about is where we say sine of 20 degrees is H over 5. So the height is going to be 5 sine 20 degrees, which is why we wrote that. And you're comparing it with 2. Either it will be greater than, which will give you 2 triangles, equal to, which will give you 1 triangle, less than, which will give you no triangles. So again, if you grab a calculator, 5 sine of 20 is going to be 1.71. So it's equal to 1.71 or 1.7, which means it's greater than. So immediately, this means there are 2 triangles. There are 2 triangles. So we're going to solve both of them right here. I'm going to erase some of the work at the bottom here. We don't need that anymore. Now, there's going to be an obtuse and an acute triangle for your reference. I'll draw them out right now. So in the first case, it's going to be like that. And of course, I can draw a second triangle, which will look, roughly speaking, something like that. And to be clear, again, this second line that I'm drawing in green is really this triangle right there. So it's really 2 triangles that I'm drawing separately. You can go back and put in the same numbers, though. This is still going to be 20 degrees. That's still going to be 5. That's still going to be 2. Now, this is triangle GHI. So this is I. So the first step is to find angle H. Sine H divided by 5 equals to sine of 20 degrees divided by 2. Now, there are 2 answers. Your calculator is only going to give you 1, but you have to use your skills to find the second one. You grab a calculator, 5 times sine of 20 divided by 2. Inverse sine of the answer is going to give you the first angle, which is going to be 58.8. But you know that's not the only answer, because in the second case, where it's going to be obtuse, you take 180 minus that, which will give you 121.2 degrees. So again, we're kind of hopping in both cases back and forth. But if I erase this line now that you understand the 2 triangles, you can take 180 minus 20 minus 58.8. That's going to give you 101.2 degrees. In the second case, 180 minus 20 minus 121.2. That's going to give you 38.8. So again, the hard part's over because you can now solve for the remaining side, which is length I. Now to find I, we're going to do this twice. The first step is you take I divided by sine of 101.2 degrees, which equals to, go back to the original, 2 divided by sine of 20 degrees. So again, if you grab a calculator, 2 times sine of 101.2 divided by sine of 20 That's going to be approximately 5.7 centimeters, which I'm going to label right here, 5.7 centimeters. And if you look at the triangle, logically this makes sense. 5, 2, 5.7, it fits. In the second case, you're going to take I divided by sine of 38.8 degrees, which again equals to 2 divided by sine of 20 degrees. So now if you grab a calculator, 2 times sine of 38.8, divide that by sine of 20. The second possible answer is going to be approximately 3.7 centimeters. And again, if you label this 3.7, 5, and 2, this all fits perfectly relative to the diagram, just like that. Example 6b, same question. The difference is the information. So again, in this case, you want to draw a triangle. You want to figure out, is it going to be one triangle, two triangles, or no triangle? As always, I'm strongly encouraging you to start the angle at the left bottom corner. So angle X is going to be 43 degrees. The other length is going to be 2 meters. You're comparing it to 4 meters. Again, not to overstate this, either it will form two triangles like that, or it will form one triangle like that, or it's simply not long enough to even connect to form any triangles. Find out. What you're really comparing is 2, 4, sine 43 degrees. If it's greater than, two triangles. Equal to, one triangle. Less than, no triangles. You grab a calculator, you press 4, sine of 43 degrees. It's going to be 2.7 approximately. So this is going to be less than. So this is one of those cases where because 2 meters is not long enough to reach to the other side, it's not going to form a triangle at all. That's all you need to state, and you are done. Example 6c. Again, if you look at this example, and I guess there is the obtuse case, I just recognize that. This is obtuse. So there are 5 cases, by the way, when it comes to the ambiguous case. If you've been watching the video up to this minute, I've talked about the 3 cases. No triangle, one triangle, 0 triangles for the acute triangle. But when it's obtuse, there are 2 other cases. Let's talk about that. If triangle ABC is given, angle B is going to be 104.5 degrees. What happens? Well, you're still going to draw a diagram, except the left bottom corner is going to look more like that because you have an obtuse angle. And of course, this is not drawn to scale. So maybe I'll draw it again like that. Now, we know angle B is going to be 104.5 degrees. Again, what is B? B is going to be 3.9. So I'm going to go back. I'm going to connect them. Now, even when it comes to the obtuse triangle, there are 2 cases. Case 1 is going to be it forms a triangle. And case 2 is it doesn't form at all. So we can still kind of go through the steps to find out. And what you're doing is you're comparing 3.9 with 1.4 times sine of 104.5. So again, if I grab a calculator, I take 1.4 times sine of 104.5. That's going to be 1.36 approximately. So it's greater than. Now, this doesn't tell you there are 2 triangles. It just means there is a triangle. So again, for the obtuse case, either it will form no triangles or it will form one triangle only. You're not going to get 2 triangles if the angle is going to be obtuse. So you go back and you label everything else. This is going to be A, length A, B, C, and length C. And I go back. B is given to be 3.9 meters. C is given to be 1.4 meters. And now we can solve for everything else. Now to solve for angle C, again, what you can do is you can apply the sine law. I'm going to erase this now so there's more space. So for example, you can say sine C divided by 1.4 equals the sine of 104.5 degrees divided by 3.9. You can grab your calculators. Let's find the angle. 1.4 times sine of 104.5. Divide that by 3.9. Take the inverse sine of the answer. This is going to be approximately 20.3 degrees. I go back. I write down 20.3 degrees. To find angle A, you take 180 minus 20.3 minus 104.5. That's going to be 55.2 degrees, which means the only unknown left is to solve for a. Again, you can apply the sine law. A divided by sine of 55.2 degrees equals to, go back to the original, 3.9 divided by sine of 104.5 degrees. You grab your calculators, you work it out. 3.9 times sine of 55.2, divide that by sine of 104.5 degrees, and this is going to be approximately 3.3 meters, which I'm going to go back and label right there. And that is how you do example 6C. Great starter, great finisher. Here's the last example, 6D. Triangle KLM, there's angle L, which is going to be 26.1. There's length M, 6.5 meters, and of course length L, 4.2 meters. Again, we already did this question, by the way. That's the hint I'm giving you. Please pause the video, try this. And when you press play again, I'll be here, and we're going to finish strong together. Welcome back. Here's the first step. Draw a diagram. Again, if you think about the angle, I'm going to put that on the left bottom corner. That's going to be 26.1 degrees. That's angle L. We also have 4.2 and 6.5. And what you're trying to do right now, again, is you're comparing these two cases. You want to compare the length 4.2 relative to the height, which is 6.5, sine 26.1. Again, if you grab your calculator, 6.5 times sine of 26.1, that's going to be approximately 2.9. So this is going to be greater than, which means there are two triangles. Something I made reference earlier in example 6. So we did this. We're doing it again. So once you recognize there are two triangles, here's the first one. Here's the second one. Again, it's not drawn to scale, but one's going to be acute, one's going to be obtuse. You can go back and label the other sides. So for example, this is M. Same thing here. This is going to be L, which is 4.2 meters, capital L, and the angle is going to be 26.1. And there's also the third side, which we're going to denote as K, just like that. So we go back, and the first step here is to solve for angle M. How do we do this? Sine M divided by 6.5 is going to be equal to sine of 26.1 degrees divided by 4.2. There are two answers. One, the calculator can give you. The other one, you have to calculate. So you take 6.5 times sine of 26.1, divide this by 4.2, take the inverse sine of that answer. It's going to give you approximately 42.9 degrees, which is the acute angle. If you take 180 minus this, it's going to be 137.1 degrees. Again, if you take 180 minus 137.1 minus 26.1, this third angle is going to be 16.8. Likewise, in the first triangle, if you take 180 minus 26.1 minus 42.9, that's going to be 111 degrees. To find length K, K divided by sine of 111 degrees equals to, again, go back to the original, 4.2 divided by sine of 26.1. If you work it out, 4.2 times sine of 111 divided by sine of 26.1, that's going to be approximately 8.9 meters. Last but not least, if you take K in the second case, divided by sine of 16.8, which equals to, again, 4.2 divided by sine of 26.1, K is going to be, you take 4.2 times sine of 16.8 divided by sine of 26.1. That's going to be approximately 2.8 meters, respectively. Again, if you look at the triangle, 6.5, 4.2, 2.8, that makes sense. In the first one, 6.5, 4.2, 8.9, that still looks logical. And that's how you do example 6D. I hope this makes sense.